Hello, good day viewers. Welcome to another mathematics presentation. So in this presentation, I want us to answer this question. This is a question coming from Trigonometry Identities. So the question reads, prove the following identities. So we have our first one right here. Sin theta cot theta is equal to cos theta. So how can we prove this identity? So in order for us to prove this identity, we need to inspect our equation. So on the left hand side we have sin theta cot theta, on the right hand side we have cos theta. So you can either use the left hand side or the right hand side to prove one another. Okay, so now in this case, when you look at the left hand side, we have this, so it's easier to use the left hand side to prove the right hand side. So we are going to write, we are going to say sin theta, then we have cot theta, okay, is equal to cos theta. So now from here, what you are going to do is you take a look at this identity. We have cot theta. So for cot theta, we must know that it gives us an identity which is cot theta gives us cos theta over sin theta. So in this case, I'm using the left hand side to prove the right hand side. Okay, so here we are multiplying this and this. So I want to see if it will be equal to the right hand side where we have cos theta. So now, since cot theta it has given us cos theta over sin theta, we can check. Since we are multiplying sin theta times cos theta over sin theta, we can cancel. Here it's a 1, even here it's a 1. So we are going to remain with cos theta is equal to cos theta. So we can see that it's proven. So we just write hence proven. So this is our answer. Okay, so we have answered our question 1. Let us now move on to question 2. Alright, so we now come to our second question right here. We need to prove this trigonometric identity. We have cosec A minus sin A over 1 plus cos A equal to cot A. So here we have the left hand side and the right hand side. So remember what I said, we can either use the left hand side to prove the right hand side, or we can use the right hand side to prove the left hand side. So in this case, you need to inspect. Okay, so it's very easy to use the left hand side to prove the right hand side. Okay, so what we are going to do is we are going to look at this cosec A. So cosec A, this is the reciprocal of what? Sine, this one. So if it's the reciprocal of sine, it's going to be written as 1 over sine A. So I've said this cosec A is the reciprocal of sine. So the reciprocal of sine is 1 over sine A. Then we write minus sine A over 1 plus cos A. So now, what are we going to do? So what we are going to do from here is this. We can make this as a single fraction, okay? We can make it as a single fraction by doing this. So we are going to take sine A, okay, as our common denominator. We even take 1 plus cos A. Okay, so once we do this, we start dividing. Sine and sine will cancel. You remain with 1 plus cos A. This times 1, you get the same thing, which is 1 plus cos A. Minus, again, we divide 1 plus cos A into these denominators. So 1 plus cos A will cancel with 1 plus cos A. It's a 1, so give us a 1, we divide. We just remain with the sine A. So sine A times sine A, this will give us sine squared A. So I hope you are following. Then from here, what are we going to do? Okay, what are we going to do? So from here, what you are going to do is this. Since we have 1 plus cos A minus sine squared A, this is what we have. So what you are going to do here is this. We know that we have 1 here, and we have this trigonometric identity where we have cos squared A plus sine squared A. This gives us a 1. So where there is this 1, we are going to put this. We are just going to put this, which is cos squared A plus sine squared A, right here on 1. So we are going to write cos squared A plus sine squared A. So I've substituted where there is a 1, I've put this. Okay, then plus, we can see there is a cos A right here, cos A minus sine squared A over, we have sine A in brackets, again we have 1 plus cos A. I hope you are following. Alright, so from here now we can see we have cos squared A plus sine squared A plus cos A minus sine squared A. What is common? Sine squared A is also common here. We have sine squared A. Now this is a positive sine squared A. This is a minus sine squared A. So this means that this and this will cancel. Okay? So you can cancel this and this because of the minus here. So what are we remaining with? We are remaining with cos squared A. You write cos squared A, then plus cos A, plus cos A. This is what you remain with, okay? So I hope you are seeing what we have here, okay? Then we say over sine A in brackets and 1 plus cos A. Then from here, what are we going to do? So from here, what you are going to do is this. You look at the numerator, you have cos squared A plus cos A. What is common? The cos is common, so you can factor out the cos A. Open bracket. Here we have cos squared A, so if you remove 1 cos A, we remain with cos A. Plus cos A into cos A, it's a 1. Okay? So on top, we have factorized, we are getting this. So we have remained with sine A, then 1 plus cos A. This is what we have remained with. So from here now, what are we going to do? What are we going to do? So from here, what we are going to do is this. You can see cos A plus 1 is the same with 1 plus cos A. This and this, they are the same. Okay, so this and this will cancel. You get the ones here. So what you remain with is just cos A over sine A. This is what you remain with. And we have the trigonometric identity for this one. Cos A over sine A, it's cot A. Now remember the question. They said this is equal to the right hand side, and the right hand side was cot A. So you can see that we have solved the left hand side. Okay, it has given us cot A also. So we can now equate. We just say cot A is equal to the right hand side because we also have cot A on the right hand side. Then we even write hence proven. Okay, hence proven. So this is the answer. So thank you so much, everybody. We've come to the end of our short presentation. This has been your presenter, Mr. Mrenga. Bye bye.